So today I asked some folks and see during class if they would be willing to write down a couple questions on their whiteboard to find out which questions they'd like me to review. But we ran out a little bit of time because of our early release, but I don't want to lose any time, so I'm making some videos kind of reviewing number 13. There's specifics about 13B, but I am also going to briefly go through 13A. So here the question is, two students determine the percentage of lead in a sample as a laboratory exercise. The true percentage is 13.22%. The students' results for the three determinations are as follows. So I've written that down, and it's asking me to calculate the average percentage for each data set and then state which set has the more accurate based on the average. So each of these numbers here, those are considered to be the percentages already. So here we are. I'm going to kind of zoom into my paper here. Notice I've already written it down, and I'm just going to do this is going to be a pretty quick little calculation. So as a reminder, how to do averages. So I would take 13.18 plus 13.21 plus 13.24. And because there's three different data sets, I would then divide that by 3. So then I'll use my calculator as we're getting it up here on my calculator. So I would then, I'll enter it. You might not necessarily see me enter it, but you'll see me on there. So I'm going to zoom up a little bit. Here we go. We've got 13.18 plus 13.21 plus 13.24. I'm going to enter, or I could put the whole thing in parentheses and then divide by 3, but because I hit enter, I can just then divide by 3. And then we end up with 13.21%. Awfully close because we're actually looking for 13.22%. That is what we're looking for. So the calculation is 13.21. Then again, going through, then we go 13.11 plus 13.08 plus 13.14. Again, still only 3 data points, and we then calculate our mean here. I'm going to scoot this up. And we end up with, so 13.11 plus 13.08 plus 13.14. Again, hitting equal, not using parentheses, and divide the whole thing by 3. And we end up with 13.11. So thinking back to where we are looking for our most accurate, so this is our data set A and this is our data set B. So we are looking to see what is going to be closest to our bullseye. Remembering accuracy, we're looking for getting closest to this middle point. We want, so if you're, the one quick way to do it is to figure out which one is more accurate. I mean, you can probably figure it out in your 13.21, and then you can then subtract that, and we get the absolute value. You end up with a difference of 0.01, and here we have 13.11 minus 13.22 absolute value. Then your difference is actually going to be, I'll scoot that up. The difference here is going to be a difference of 0.11. So this data set A here is going to be more accurate, hitting that bullseye. So now we have to look at the precision, and that is where actually the original problem was. So precision, there's many different ways to actually calculate the precision, but this is probably your quickest route, and this is a route that we're going to use in class. So I've actually already set up our formula for doing our mean absolute deviation, or I'll just call it absolute deviation here. So what we do, so looking back to algebra and maybe even calculus as well, is remembering that these lines mean our absolute value. So this is our general form. You take a data point and you subtract it from the mean, so you always need to calculate the mean first. Get data point, subtract it from and you add that to the absolute value, and you then divide the whole thing by the number of data points. And then that's how you can calculate what your precision is. So I'm going to be referencing back and forth here, but I'm not going to scoot back and forth each time. I'm just going to fill in the data for this first one. So our first one is going to be, our mean is 13.21, so we're going to use that 3 different times. So then we end up with, for our first one, 13.18 minus 13.21. Remember, we're going to do the absolute value, so that's just the magnitude it is from 0, not anything to do with negatives and positives. Then we're going to add that to 13.21. We're going to subtract 13.21, so that's going to be 0, and we already know that one. So then we're going to add that then to 13.24 minus 13.21. Absolute value. So I'm going to scoot that over a little bit so you can still see within the picture there, doing my best. So dividing that whole thing by how many data points? You said 3 really quickly, you are correct. So then you divide by 3 different data points. So recalculating that quickly, so the absolute value, I'm going to put my calculator in here, we do 13.18 minus 13.21, we're going to end up with the absolute value of 0.03. We're then going to add that to 0. Add that then 13.24 minus 13.21. We're ending up to, going to do the absolute value again. So we end up with 0.03 plus 0 divided by 3. So then we end up with, I'm going to scoot this up a little bit, 0.06 divided by 3. So then 0.06 divided by 3. And we end up with a precision of 0.02. So that is just for our data set A for our absolute deviation of that. So that's where we're going for B. So that we're looking to see which is going to be more precise. And please remember, we're looking for a number that's going to be smaller than 0.02, or to be more precise, it would need to be smaller. To be less precise, we are going to then need to be bigger than that. So it's counterintuitive on that. So I'm going to then also, I'm going to move on to B. I'm going to switch my page here. So this here, we're going to again do the absolute value, because figure out the way I'm going to arrange this. So we're going to end up with the absolute value of 13.11, minus, our mean is 13.11. So I'm going to then add that to the absolute value of 13.08. Going to minus that, subtract that from 13.11. Again, that's going to be absolute value. And then lastly, we're going to 13.14 minus the absolute value of there. And again, same number of data points. We're going to divide the whole thing by 3. And then this will help us determine what the precision is of this problem. So then we end up with, I'm going to scoot that over. Try my best to kind of squeeze it in there. So end up with 13.11 minus 13.11. So then we end up with 0 plus 13.08 minus 13.11. So the absolute value is 0.03. You might start to see something very similar compared to the other one. So then again, very quickly glancing, 13.14 minus 13.11 is the absolute value. Magnitude of difference is 0.03. Again, it's same as that as the other one. So that will, quick glance, again, that is 0.06 divided by 3. Again, the precision is 0.02, so they are both identical. So the answer to our problem is both sets are equally precise. So that's what we'd be looking for on our answer here. So both sets are equally precise. If you have any questions about this problem, please feel free to come to the office hours on Wednesday morning or Thursday morning at 7:30 a.m. and I can help you out. Again, I had mentioned this to a couple of you. This part will not actually be on Unit 1 quiz, but it will be on Unit 2 quiz. So it's going to come back to visit throughout the rest of the semester. All right, take care. Send me a remind message or email me again at mday@pps.net.